Mr. Mitchell with a video about electricity basics. When it boils down to it, electricity has to do with charges, like positive and negative charges. And you've heard of positive and negative charges in magnets and magnetism. You've studied that before. If you have a magnet with a north end and a south end, you have positive on one end and negative on the other. And whenever you put two magnets together, sometimes they repel. Sometimes they refuse to go together. And that's when you have a positive trying to attach and a negative trying to attach. Same thing in electricity. When you have like charges, they tend to repel against each other. When you have opposite charges in the magnets and in electricity, that's when you get that attraction to them, when they have the positives and the negatives. Opposite charges attract while like charges repel. Now we have diagrams where you can show these attractions and repelling nature of these positive and negative charges. And you can see here the negative have all the arrows coming to them, the positive have all the arrows going out. And whenever you have them together, you either have something like this, where you have charges that are repelling or charges that are attracting. Now, by having these lines, that shows you that it's not just one independent unit that is just waiting for something to have contact with it before it either repels or attracts. If you have two magnets that are attracted to each other, once you get them close, they tend to come together without your input from it. And kind of the same thing is true with electricity. You don't have to be right upon the doorknob, for example, for electric charge to go from the doorknob to your hand. Here's an example of, this is kind of funny, online they have a John Travoltage, and here's a picture of John Travolta on a rug. In this simulation, you move his feet on the rug and it builds up charges, and the charges will eventually attract the negative charges from the doorknob, even though he's not touching the doorknob. So you've had that example where you've rubbed your feet against carpet and you ended up sometimes being able to shock someone or induce a shock from a metal object. This is an example of having positive and negative charges. You have created the negative charges and the positive charges polarizing in your body, and since they are polarized, you are more easily able to get charges from something else coming to you. And that's true also with this balloon and this head of hair. When you rub the balloon on your head, then you are polarizing the positives and the negatives. And in some cases, or many cases, you're able to then bring the balloon close to somebody else's head and bring the hair up. You have the positives and the negatives that are attracted to each other. And that's what scientists think is going on. You can use friction to induce the positives and negatives to end up moving from one place to another. Even on a plastic rod, you can induce the positives and negatives to being polarizing, and that would attract the positives away from the negatives on something else. Now, this is just like magnetism. You do have positives and negatives. You do have, in this case, with the electrons, with the positives and negatives, we have these electric field lines, which is what these are called. With magnetism, you have magnetic field lines. So if something on the north end of a magnet gets anywhere close to the south end of a magnet, it attracts to it. Same thing with these negative charges. If you get a positive that is anywhere close to it, it will be attracted to it. So what does that have to do with electricity? Electricity, you can see from this diagram, is a flow of electrons around a circuit. Now, where do the positives and negatives come in with that? An electron is a subatomic part of an atom, and it has a negative charge. So when you have electricity as the flow of electrons, you are talking about the flow of negative charges around a circuit. Here we have a battery. A battery has one end, the top, and the other end, the bottom. On the top, it has, I forget whether it's positive or negative, but I think it's positive. If you look on a battery, you can see one end says positive and one end says negative. So if it's positive on the top, it would be negative on the bottom. So you can induce by taking a wire or some kind of conductor, some kind of wire or conductor, and attach it to, say, a light bulb or lamp, and then attach it to the other end of the battery. Then you can have negatives flowing all the way to the positive end. And since those negatives are flowing to the positive end, the electricity is the flow of these negatives around a circuit, the flow of these electrons, and it produces the light. So when you have movement of these negative particles, you can have electricity. Now, something ironic is the flow of electricity is opposite of the negative parts, but don't let that confuse you. Whenever you do have a flow of negative parts or electrons around a circuit, you have electricity regardless of which way it flows. Now, we can actually have a unit that we measure electricity by. Now, we normally don't use coulombs. The standard unit is going to be coulombs. You're going to end up seeing words like amps and voltage later on as we discuss electricity. That's what we normally use, amps and volts. But coulombs play a part of it, and that's kind of the basis of simple electricity is going to be this unit, coulomb. A battery has about 9,000 coulombs in it, and a coulomb is equal to a huge number. I don't know if you can see it here on this diagram, but it's a huge number of actual electrons that are moving. It's like 6.25 and 16 zeros after it, actual electrons. Now, you don't have to know that 6.5 with 16 zeros after it actual number. Just know that there is a lot more electrons than you can count, really, in one coulomb. And a coulomb is a unit of electrical charge. There's about 9,000 coulombs in a AA battery like this. Now, one final term or two final terms is insulators and conductors. When you have electricity which is flowing, you kind of have to have it through something like a conductor, and you see key and nail and nickel and things that are mostly aluminum, not aluminum, but mostly metal in here. Now, it says jar lid. That has to be some kind of metal jar lid. These things that are metal are better conductors than things like clothespins and rubber bands and cardboard strips that are not metal. The things that do not conduct electricity or heat very well are called insulators. The things that do conduct heat and electricity very well are called conductors. So know these terms, insulator, conductor, coulomb, and kind of the basics of the positive and negative flow of the positive and negative charges, which ends up being electricity. Hope you learned a lot.